Hello everyone. Today we're going to be writing a Spring Boot application with a GraphQL backend. GraphQL.org provides us the definition of GraphQL as a query language for your API and a server-side runtime for executing queries by using a type system you define for your data. GraphQL isn't tied to any specific database or storage engine and is instead backed by your existing code and data. A GraphQL service is created by defining types and fields on those types, then providing functions for each field on each type. So, GraphQL is an alternative way of writing APIs. Currently, we are very familiar with RESTful APIs, and they're very powerful. But with GraphQL, you can specifically ask for specific data that is needed and ignore anything else that is not needed for your use cases. Now, we're going to be creating a new Spring Boot project and try to learn GraphQL as we go. We start off by clicking create a new project. We're going to use the Spring initializer in IntelliJ. We're going to give the group name as com.tutorial.springboot.graphql. We're going to name it Spring Boot GraphQL tutorial. We would like a Maven project and the Java packaging jar, version 8, and we keep the same for the rest here. Rather than having it called this way, we're just gonna leave it to SVG. And then we are going to be using, just leave the defaults. That's the project name, that's the project location, finish. So for every Spring Boot application, we would need to create an application.java class. So let's enable auto imports here. Go to source, main, Java. And this is the main class where it has the actual annotation and it has the Spring Boot application run. It seems that 2.26 is not available, so we're just going to change to 2.2.5, and now we should be able to resolve all these issues. And then if we go back to the main application class, now it looks good. So it's a Spring Boot application and it runs the application here. Now, next step is to provide the actual services and the controllers for this application. The very important step here for GraphQL to be understanding how we need to query that data, we need to create a file that the GraphQL engine will be able to read and understand what the data looks like. And we have to define that file inside of the resources folder here. We'll create a new directory and we call it GraphQL. And then inside of the GraphQL folder, the main file should be called whatever you are trying to, the domain that you're trying to work with. So let's try and talk about, vehicles. So vehicles here, ql.graphqls. So that's the actual extension of that file that it needs to be in. Okay, so we start writing up the content of the data that we're trying to query or mutate. So since we're talking about the context of vehicles, first of all, we need to define a type called vehicle. And in the vehicle, we can define an ID, and the exclamation mark here means that the ID has to be mandatory. We give another field called type, and that's a string value. Let's give another field here. Let's define the model of the vehicle, and that's also a string. The year of the vehicle, let's also define that as a string. Now, so we have our vehicle object type defined. Now the next step is to have GraphQL understand what are the methods that you would like to query by. So let's create a type query here, and we would like to fetch data for vehicles, and let's give it a max result count, and that would be an integer value, and that method will return an array of vehicle objects. And let's define another method where we can get only one vehicle back by ID, and that would return us a vehicle object. Now the query part we're done with. Now in case we would like to do some sort of an update or CRUD operations, or what we call GraphQL calls it mutations, we have to define a type of mutation here, and then we'll create something called create vehicles, or vehicle one, and then here we can pass in the information for that vehicle, such as the type as we defined in the object, and it's a string mandatory. Also type, the model, which is also a string, and it's also mandatory to be available. The model of that vehicle, also a string, mandatory, and the year. So here we will make sure that this method returns back a boolean of a true or false based on the operation success. In order for the GraphQL engine to understand how to read this file, we would need to create a GraphQL, what they call a GraphQL resolver. So we would need to create two classes. One class is a GraphQL query resolver, and the other one is a GraphQL mutation resolver. And in order to do that, we're going to be creating here a new package, and we would name it something like a domain.vehicle.graphql, and in there we're going to create a new class, and we will call it vehicle query. Now, to start off, we have to implement a query or a GraphQL query resolver, and in that case we have to do implements GraphQL query resolver. Obviously we have not added that in our dependency in our POM, so we're going to go ahead and add that. So we're going to the POM file, and not only add the GraphQL, but we will be adding more dependencies here. So one of the dependencies we would need is the actual the web starter. So that's going to be org.spring framework, and then the artifact would be starter web. Another dependency would be another starter. This time we would need a GPA starter to get the data and map it. So that would be part of this Spring Boot framework as well. Boot, and then in artifact we are going to be adding Spring Boot starter data and then JPA. Okay, and then another dependency would be the actual dependency of GraphQL. So here we're going to be saying dependency. The group ID would be com.graphql Java, and then in the artifact we are going to be using GraphQL spring boot starter, and the version we are going to be using is 5.0.2. Now another dependency which we'll explain more about here would be the dependency of GraphQL, which is an interface to do the actual querying of the data. We will look into that later. So in here we are going to be also trying to get the GraphQL-Java group, and then the artifact would be GraphQL starter. Another important dependency would be the, besides that we need to define the version here, which is 5.0.2, and then another dependency would be adding the tools. So com.graphql-java, and then the artifact would be GraphQL-java-tools. And then we would have to define the version, which is, we'll be using the 5.2.4. And then one last dependency is having an internal database called H2 database. So no need to create an actual database server. We can have our own internal H2 database here. That would be H2 database, and that will be running only, the scope of it is just make sure that it runs and available on runtime. All right, so now we have all the necessary dependencies to continue working with GraphQL. Going back to our vehicle query here, we see that the interface here got resolved and we're good to go here. So let's start working on this vehicle query. So we define it as a component annotation here to be available at the Spring container as a dependency. And then we are going to be writing an actual service to service the information and the data that will be mapped from the H2 database, that instance that we're going to be creating, and then we have to map that information over to the GraphQL query resolver. So we are going to start working on creating a service for us. So the service would be something like vehicle service, which is not defined yet, but we will be defining it very soon. And then in Spring Boot, it's part of the best practices is to use constructor injection, and that's what I've been using most of the time. And here we are going to be creating a new constructor that takes in the actual service as a dependency, and we make sure that the dependency is mapped to the correct private variable here within the query resolver. All right. So as we recall, going back to the actual GraphQL schema file, for the query we defined two methods. We have a vehicles that takes in a count as an integer parameter and returns a list or an array of vehicles back, and another method which is a vehicle which takes in an ID as a parameter and returns back to us a single vehicle. So we need to define those two methods inside of the query class, and that's where the magic happens, is that the query class here will be able to understand the schema, and based on what the schema definition, the query will be able to understand that and return the data needed when the querying operation happens. So we are going to write up those two methods in this class. IntelliJ here helps us try to create those offhand, but the very first thing we would need to create is the actual interface for that service, and that interface would be part of the vehicle. Let's try and define that as part of the domain of that vehicle. So in there we would have a model package that is not created there yet, and in there we would define the actual interface, and then in that interface we would have the following methods. So we define the actual query methods that we were talking about. The first one would be the list of all the vehicles, and that would be get all vehicles, and it takes in the count, which is or the max results that you would like to have back. And then another method, which is using the optional Java 8 of the actual vehicle model, and that would get us only one vehicle, and the actual parameter would be the ID. Now we need to also define the actual vehicle model here. So we have to create a vehicle class, or more likely an actual entity class, and that will be also part of the model. The vehicle class here is an entity class that maps what the data in H2 database is going to be serialized, and will be creating that object in that vehicle. So we start off by saying that the vehicle should be implementing the serializable interface, and then in there we are going to be defining those fields of the vehicle. So the first one would be the actual ID. We also are going to be defining the type of the vehicle. We are also going to be defining the model of that vehicle, and then finally the year. And for the entity class, we need to also annotate those fields. So this one is an ID, as we are aware of, and the column annotation here, we are defining what that ID does. The name of it will be ID, and also it's not nullable, so it has to be always available for us. And we want that ID to be auto-generated. So we have to give it that annotation of generated value. And the strategy of doing that is by doing it auto-generation. So the generation type would be auto. Next, we move on to the type. The type, we just define the column here as a name equals type, and nullable, let's not make it nullable, make it mandatory here, and then define another column for the model, name, model, and then the year. Name equals year. And then we are going to be defining the getters and setters and the constructors of this entity. So here we have defined the constructor. We are going to be defining the getters, the setters here, and then finally, for every model, it's a best practice to create the equals and hash code methods, as well as the toString. We have to overwrite that as well. Here we are done with defining the vehicle. If we go back to the vehicle service here, we need to import a couple of classes here. We need the list and the optional. And now the vehicle service is available for us. So in order to get the data from the H2 instance, the internal instance of this application, we have to create a repository. And if you guys remember, we added a dependency of not only the H2 database, as well as the GPA helper here that would actually map that data for us, and it'll give us a quick way of querying that data. So if for that, we need to create a new interface, and that interface would be called vehicle repository. And that's going to be an interface. And that, in order to use the JPA interface, we have to be implementing, it has to be extending the JPA repository. And we define the JPA repository by saying that it requires the actual mapping of the vehicle. So we have to define the vehicle object here, as well as the ID, which is an integer ID. And here we have an interface, a repository interface, and we have to define it as a repository so that the Spring container will be able to understand and make sure that the vehicle repository is available as a dependency for the service. Now we have the interfaces available for us. We are going to be writing the implementation for the service interface. So I'm going to be creating a new package called impl. And inside of the impl package, we are going to create a new class called vehicle service. Let's call it default vehicle service. And it's a class. Here, we are going to make sure that it implements the service vehicle service, and then we annotate by a service annotation here provided by a stereotype from the Spring library. Now we are going to be implementing the methods. So in order to be implementing those methods, the very first thing we need is the dependency of the repository. So we define a vehicle repository here, and we define it by that variable name, and then we're going to be creating a new constructor that takes in that dependency as an injection, dependency injection. Then we are going to be creating the actual methods, or the actual implementation of those methods defined in the service implementation service interface. So here we are going to be saying we are going to override the interface, and then we are going to say vehicle get all vehicles, and it takes in the count. And basically this would return the vehicle repository dot find all dot stream dot limit, which is the actual count limit, and collect all that data and map it to the collectors list so that it'll transform it into a list. Then here we need to import the list. So here we have the definition or the implementation of get all vehicles. It takes in the count or the max or the limit, and it should return a list of vehicles for us. And this is the JPA implementation that will help us get that data. And let's add also, make sure that this is a read-only transaction. So functional, and then this is a read-only true. And it seems like we have imported the wrong class, so we need to make sure that we are getting the correct transactional. Nope, we need the Spring Framework one. So here, go back and define the Spring Framework annotation. Now we're going to create the implementation of get vehicle. So we're going to override as well. And that would be a public optional of type vehicle get vehicle, and it takes in the actual ID. Here we're returning an optional of dot auth, and then we are going to be calling the repository dot find by ID, and we pass in the ID, and then as part of the optional we have to say get, and there you go. Here we are going to define the implementation of get vehicle that takes in an ID as an integer, and it should be returning an optional of a type vehicle, and we are using the vehicle repository JPA to find by ID and return it as an optional. We're going to define also the transactional to be as read-only. Now we have defined the service implementation. We go back to the GraphQL vehicle query resolver. And since the service implementation is ready to go, now we need to define the methods of the query inside our schema. So we would need to define those two methods in the query resolver. So to do that, we are going to define a vehicle, list of vehicle by get vehicles, and it takes in an count. And since we have the service available for the vehicle service, so we return vehicle service dot get all vehicles, and then we pass in the count. And then let's import the list. So basically we need to make sure that the name of the method that we define in the resolver has to match the name of this method here in the schema, but we have to add a get in front of it and with a capital V. And we will do the same thing for the vehicle. We go back to the vehicle query and we define the get vehicle by ID. So that returns an optional and of type vehicle, and we name it vehicle get vehicle that takes in an ID, and that will return this dot vehicle service dot get vehicle, and we pass in the ID. Now that should give us a way of querying vehicles, and that the setup of that would be done for GraphQL. The next step is to go ahead and start working on the mutation on how to create a vehicle. And in order to do that, we need to define a mutation resolver. And just like what we did for the vehicle query, we're going to create a new class that is a vehicle mutation class that implements a GraphQL mutation resolver. So we'll go back to the GraphQL folder here, create a new class, and we name it vehicle mutation. And then that mutation implements GraphQL mutation resolver. And we make sure that it's a component. We declared the service, service, and we name it vehicle service. We create the constructor for the dependency injection, and then create vehicle. And just to recap, we go back to the schema and we take a look at the mutation type here. It's a create vehicle method, takes in a type, which is mandatory string type, and model, as well as the year, and we make sure that it returns a boolean. So in the mutation, we pass in these values: type, model, and the year. So now we are going to create a new method inside of the vehicle service to help us do the mutation for GraphQL. So we first go to the vehicle service interface and we declare the method create vehicle, takes in the type, the model, and the year. And then we're going to the default vehicle service implementation, and we create it here. It's going to be a transactional, and we override the interface here, and then we're going to declare it and implement it in this method. So public void create vehicle, takes in the type again, the model, and the year. And in order to be using the JPA repository, we have to create a new instance of a vehicle, and we pass in those values in there. So this is going to be a final vehicle. Vehicle equals new vehicle. And it's going to be taking the type, the model, and the year. Then we're going to call the service the repository, which is .vehicle repository .save, and we pass in the vehicle instance. So now we have created the implementation of the create vehicle. We go back to the mutation and we call it here. In order to do that, just simply say this .vehicle service .create vehicle, and then we pass in the type, the model, and the year. And we return true to make sure that the vehicle has been created. We return true, and the mutation here is done. As I was going through the code, I realized that I forgot to make the vehicle class here an entity. And in order to do so, we need to add in the entity annotation at the top of the class, and that defines the vehicle as a dependency available for others. And as a requirement for an entity class, we need to make sure the vehicle has a public no-arg constructor. So we are going to declare it right here. And now the vehicle is ready to be used for others. If you recall, we added a dependency in the prom file that is called a GraphQL dependency. And what GraphQL does is a way of us to understand how we can query and do the mutations of data in GraphQL, which is a tool that helps us in doing so. Rather than using the application itself to look at the data, we can use this tool to do the querying. And in order to do so, it needs that dependency to be available in the POM, and the endpoint to access that would be GraphQL/GraphQL. Now, another thing that you have probably realized that we did not have to create a controller for exposing those endpoints, because by default, GraphQL in Spring Boot already has a definition or an endpoint with /GraphQL at the end of the application host or IP. And in order to do, you can change that in the application properties or the application YAML definitions in Spring Boot to change that endpoint name, but by default, it is actually defined as /GraphQL. So before we go to the GraphQL endpoint, we are going to visit the GraphQL endpoint to see how that tool works. And in order to do so, we need to run the application first. And then once the application is up, we see that it started. We go to a browser and we go to localhost /GraphQL. And here a UI tool shows up, and that tool will give us a way to query the data available. At the top right hand corner here, we have Documentation Explorer, and in here it'll give you all the available queries. As we see here, we have vehicles and vehicle, and as well as the mutations, which is create vehicle. Now, the database we're using here is an H2 database, and when we start this application, the database is empty. So first of all, we're going to start creating a vehicle so that it'll be stored in the database, and then we'll do the querying. So let's go here and create a new vehicle. In order to do so, we need to define the operation, which is mutation. And then we call the create vehicle mutation here. And we start typing in the types that we want to create the vehicle with. So we have to declare the variable name and then the value. So let's say that it's a type of a car, and then the model would be, let's say it's a XYZ model, and the year of that car is 2020. And then once we execute this mutation, we realize that the data has been created and the return value is true. Now, if we are going to query that, we are going to use the query keyword here, or the query operation. And then if we go back to the schema documentations here, and let's do all vehicles, we have to use all vehicles, and then we have to give it the count, let's say of 10, even though we know there's only one of them. And then we execute. Now realize here that by automatically using the vehicles count without defining which fields you're going to display or need, by default it brought us back the ID. But here in this body of the method vehicles, we can actually query for specific data here. So let's say we want everything. So the ID, the type, the model, and the year. And then we run this, it'll give us all the information that we are requesting. But let's say I don't care much about the ID, I just want the type and the model of this vehicle. And then we run that. Then we can only get those two fields back. And that's the power of GraphQL, is that we do not need the whole vehicle information sometimes, especially for mobile applications. We want a better performance in gathering this data into one single page. That's how we query specific things that's needed for that page to load and to view the data that you're querying for. There are different ways to access the GraphQL endpoint in Spring Boot. The first option, which we just covered, is by using the GraphQL endpoint to access an internal exposed GraphQL endpoint to do the querying and the mutations. Now, another option is to use Postman or curl command in order to do that as well. But basically, for all the front-end development, there are certain libraries that you could use and leverage in order to do that. So when you create your UI and you're trying to query the data that you're looking for, you use a specific library such as Apollo library that is a client library that has access to GraphQL server to do the querying for you. But right now, we're going to use Postman as an example on how to execute that. There are different ways to access the GraphQL server instance in Spring Boot. The first way we just went through is by using the GraphQL interface to do the querying and the mutations for us. You could also use Postman and curl, just like how you execute requests for RESTful services and APIs. You can do the same thing with Postman and with the curl commands. And another way also to execute by creating a web application, and in the front end of that web application, you use certain GraphQL client libraries to have access to the GraphQL service and make those queries. A good example would be Apollo client is a good way of leverage that help and try to call the GraphQL service and get the data. Now, I'm going to be also looking into Postman, and I'm going to be launching a Postman here. Just like how you execute calls or requests to RESTful services, we initiate this request by having it become a post request with this URL. And notice that the endpoint exposed here is /GraphQL. And since this is a post request, we need to give it a body. And the body here, it looks exactly the same syntax as what we've seen in GraphQL. We provide that syntax in the body. And here we are querying for vehicles with bringing back a result of 10 vehicles. And we only want to show the ID, the type, and the model. And now we're going to send this request over. And here we get the results back with the ID, the type, and the model. Again, just like what we've done in GraphQL, we can specifically query certain things or certain fields. So here I replace the model with the year. I send this request again, and we get the year back. If you notice, there's a GraphQL option that comes in with Postman. It got introduced recently, and that option helps us to write the syntax of GraphQL within this body and send it along with the request. To recap, we started working on creating a new Spring application, adding all the dependencies alongside with it. Then we moved on into creating the actual schema of GraphQL. And in the schema, we defined a vehicle with the attributes, the query, and the mutation for that vehicle. Then we created a vehicle query that implements a GraphQL query resolver, and that needs a dependency of a vehicle service. And inside of the vehicle service, we wrote all the dependencies and all the services needed for the GraphQL calls and queries. Then we moved on into creating the mutation that implements a GraphQL mutation resolver and made sure that the vehicle service has the service to create a vehicle. Then we moved on to talk about the GraphQL interface and how to query the GraphQL server with the syntax, both mutation and query. And finally, we use Postman to be able to make those calls to the /GraphQL endpoint that is exposed in that Spring Boot application. Thank you for watching this tutorial. Please like this video and subscribe to my channel in order for me to create more content.